Hello everyone. Today I want to talk about what we're doing to improve our off-grid workshop and what we're doing to cut down the usage of our generator. I mean, there's no getting away from using a generator for us because we've got big machines. So here's our little unassuming little box of tricks. On the outside you literally have a meter which you can see shows the amount of voltage we've got, how much charged the battery is, and then coming down to this side we then have our system here. So on here we have our 12 volt direct power. That'll give us our voltage. Here I've got a couple of USBs just to charge things like power walkers, phones, other things like that. We have a 12 volt section here which is for obviously the 12 volt items, and then coming across to here we have a 4-bay bank which is then serviced by this inverter here. As you can see, that comes on, we have power. That then comes around, you can then see we're then live. You can see the lights on there. So heading up above the shipping container, up here you can see we have our panels pointing at that thing up there, the bright thing, the star. So that then means that we can then power from here, and we've got a cable running down through and comes down past here and just goes through to our box. Right, so I'm up on top of the container just to show you what the unit looks like. So you can see I've got 14.2 volts coming down from this off of the charge controller. Sorry, forgive me, it's really hard to film clambering around on a ladder and things. And then if I press this one, we should see the amperage. So I'm producing like 1.9 amps. That changes throughout the day obviously, but that 1.9 amps then goes straight down to the unit. Right, so on the nitty gritty of all of it, we've got a power walker here that I've charged up this morning, all full of solar goodness, or bar one bar. That I'll take and use for the phone later and have some guilt-free perusing, things like YouTube. So here, what I've got is the cigarette lighter socket. As you can see, that now lights up. So this is coming direct off the 12 volt. So we've got no conversion from here. So that there being the inverter. This side here, I'm just actually using a 12 volt supply, so I don't have to convert it. The importance of that is that when you convert to 240 instead of 12 volt, you have to times it by 20 to get to the voltage, which means you also increase the amount of amps that you're trying to suck up. The maths gets quite complicated, but essentially you get more bang for your buck off of a straight 12 volt supply. So as you can see on here, going across the battery and it shows, there you go. So that there is needing a charge. I'll chuck it in and there we are, we're off. And now that then is coming direct down from the sun again. So the reason I've done it this way, I'm on the floor again, forgive me. The reason I've done it in a box is so I can then mount it into the van whenever I need. It's on wheels, I can push it about, whatever else. The reason being that obviously we do market stalls and things like that. So if I want to be able to go out and charge up, for instance, our carb machine, we want to do a live demonstration, anything power-wise, we've then got a store to do it. The other thing is obviously when I'm not at the workshop, I can then chuck the solar panel and charge it up. So made it portable that way. Right, so if anyone's wondering, the battery we're using is a Bosch battery. It's a 90 amp hour. It's quite a large thing really. The reason that we're using a leisure battery is they're different to car batteries. Car battery is designed to be a sprinter. It produces a large amount of amps very quickly, but it's only really designed to start engines and, you know, get them going. Once they've gone, that's it, they're getting charged again. So for these, they're designed to do the long haul. They're designed to put out a lot of amperage over a long period of time. Less than a stop start, but obviously that allows it. With a battery, you can only actually use 50% of it unless it's lithium ion, because once it's depleted by that 50%, what you're then going to do is have trouble recharging it any further back up to that. So you've always got to be a bit careful as to how much you deplete these things. But the difference being that in terms of economics, it's about 300 or 400 quid different between that as a battery and a lithium ion version. So at the moment, on the paperwork, this unit here can only pull, I think it's 2 amps at a time. So I know just a second ago we were looking up at the roof, we were producing 1.9 amps. So I'm losing about 0.1 of an amp, which is coming from the battery, but the rest is all coming direct from the sun. So the time that this isn't charging, once that's fully charged up, then obviously then we can then recharge the battery back up to full. That's a bit of an update. Having a good look at our charge. We are now producing nearly 4 amps of power. So now what we're charging on that battery over there is now going to be only 50% of what we're producing. So we're now not only charging the battery, now charging the larger battery at the same time. Right, so I've just put the inverter on, I've taken the plug down from here, which is now running up to our scroll saw. Just to show you when we are using 240, what it's for. So for instance here, we're now off.
Ah, look at that, Geoffrey. Another fine day shining down on God's sweet Britain. Land of crumble and lemon curd and opportunity. God, I love it. I begin every sentence with an apology. Sorry that's the case, that's just British policy.